June 14, 2025. An ordinary night at the Atlas Observatory in Chile. A faint trail appears that does not fit any known orbit. Within weeks, astronomers confirm this is 3I/Atlas, the third interstellar object ever spotted in our solar system, yet one whose bizarre chemistry and unexplained radar defy every natural explanation. Some now wonder, could it even be an alien mothership? The story behind 3I/Atlas begins with a discovery that changed everything, and the facts only get stranger from here. The first confirmed images of 3I/Atlas come from the Atlas Survey Telescope at Rio Hurtado, Chile on July 1, 2025. That night, the automated system flagged a faint, fast-moving object that didn't match any known asteroid or comet. Within hours, the data were packaged and sent electronically to the Minor Planet Center, the global clearinghouse for new solar system discoveries. The official entry, time-stamped July 1st, lists the Atlas institutional tag and the Rio Hurtado Telescope's MPC code, T08. No individual names appear in the submission, just the facility, device number, and a string of UTC timestamps. Archival records later revealed that the object's trail actually appears in images from June 14, 2025, nearly 2 weeks before the official report. These pre-discovery frames, drawn from the same Atlas telescope and from Caltech's Zwicky transient facility, show the object moving against the star field, faint but unmistakable. Each image carries its own metadata: date, time, exposure, and instrument signature. The Minor Planet Center's public logs record hundreds of observations from June 14th through early July, all filed under institutional designators, never personal names. By July 2nd, the Minor Planet Center had verified the inbound data, published the official designation 3I/Atlas, and released the first orbital solution. Within days, telescopes worldwide began tracking the object. The discovery chain is fully documented, from initial detection through institutional reporting to global scientific recognition. Every link, each image, timestamp, and submission can be traced directly from the Atlas array to the Minor Planet Center. No gaps, no ambiguity, and no single discoverer. The process is collective, rigorous, and transparent. JPL's official orbital solution leaves little room for doubt about the origin of 3I/Atlas. The object's path through the solar system is hyperbolic, meaning it is not gravitationally bound to the Sun and will never return. The orbit's eccentricity, a measure of its deviation from a perfect circle, is calculated at 6.08, far beyond the threshold of one that defines a closed elliptical orbit. This single number, derived from hundreds of observations and refined across multiple facilities, sets 3I/Atlas apart from every known asteroid or comet born in our solar system. The inclination of the orbit, about 175 degrees, is another striking feature. This puts the trajectory nearly opposite the direction of planets, slicing through the ecliptic in a retrograde motion, almost a mirror image of the solar system's usual traffic. Only a handful of known objects have ever entered on such an extreme, near-ecliptic retrograde path, and none have matched the speed or angle of 3I/Atlas. Velocity tells the rest of the story. As 3I/Atlas approached the Sun, its excess velocity, measured at infinity after accounting for the Sun's pull, was about 26 kilometers per second. This is not just fast, it's uncatchable by any solar system object. The inbound direction traces back toward the constellation Sagittarius, hinting at an origin somewhere near the galactic center. All of these elements, eccentricity, inclination, velocity, and approach, combine to rule out a solar system source. The object's motion is a fingerprint, and every metric points to interstellar space. The JPL solution, listed as orbit number 1 in official records, is the foundation for all further analysis. Any theory about the nature of 3P/Atlas must contend with these orbital facts. The numbers constrain what is physically possible and set the boundaries for credible speculation. Each image and video of 3I/Atlas circulating online has been subjected to rigorous forensic review. Independent analysts, including astronomy forums and open-source investigators, have traced the metadata on key files back to the original Atlas archive. Date stamps, instrument signatures, and submission logs from June 14th through early July 2025 all match the records held by the Minor Planet Center. Compression artifacts and cosmic ray strikes visible in the highest-profile video clips are consistent with standard telescope data processing, not digital tampering. Forensic credibility scores for the main discovery media, compiled by a consortium of reviewers, place the core dataset at 90 out of 100, an unusually high mark for a viral astronomical discovery. Chain of custody checks reveal a clear path for the most important frames. Institutional tags, device numbers, and UTC timestamps are preserved from the Atlas telescopes through to the Minor Planet Center's public logs. The only weak links appear in re-encoded clips that spread across social media after July 3rd, where minor losses in quality are evident, but no manipulation is detected. Each institutional submission is independently verifiable, with no evidence of gaps, deletions, or unexplained edits. Radar data, often cited in speculative reports, tells a different story. A single FAA incident report from July 22, 2025, referenced an unexplained radar return over the North Pacific, but follow-up analysis found no sufficient correlation with the 3I/Atlas track. The official summary lists the case as inconclusive, and no ADS-B or commercial radar logs match the object's calculated position. For now, only optical and infrared data meet the standards for scientific reliability. This leaves a filtered pool of evidence, high-credibility images and ephemeris records ready for the next phase of chemical and compositional analysis. Spectroscopic campaigns targeting 3I/Atlas have delivered a chemical profile that stands out from every known solar system comet. Data from JWST's NIR-SPEC instrument on August 6, 2025, reveal a carbon dioxide to water ratio of 8:1, a figure that eclipses the volatile balance seen in almost all other comets. This excess of carbon dioxide is not an artifact of reduction pipelines or instrument error. Cross-checked ground-based observations from the VLT and Keck confirm the same trend, even as water and carbon monoxide lines fluctuate with distance from the Sun. In the coma, production rates for hydrogen cyanide reach up to 4.5 times 10 to the 25th power molecules per second, measured at 2.3 astronomical units by the James Clerk Maxwell telescope. Such vigorous outgassing, dominated by supervolatiles, begins well beyond the distances where solar system comets typically activate. The spectral fingerprints show robust CN and atomic nickel lines, but iron is conspicuously weak. Preliminary reports describe a strong imbalance between nickel and iron emissions. Nickel dominates, while iron hovers near detection limits. This metallic ratio, though not without precedent, is rare and hints at a formation environment or process outside the familiar boundaries of our solar system. Isotopic ratios, the gold standard for tracing an object's origin, remain unresolved. Signal-to-noise in the current spectra is too low to distinguish between terrestrial and non-terrestrial isotopes for carbon, oxygen, or nickel. No uniquely artificial molecules, no industrial byproducts or engineered volatiles have been detected above the threshold of 1 part per million. The chemical evidence refuses to settle into any established category. Instead, it leaves a puzzle, a volatile-rich, metal-skewed composition that fits neither a typical comet nor any known artifact and demands a new framework for explanation. Avi Loeb, a Harvard astrophysicist, argues that if 3I/Atlas shows any repeatable anomalies, like unexplained accelerations, engineered spectral lines, or non-terrestrial isotope ratios, then the possibility of an artificial origin must be examined. Jason Wright from Penn State points out that astronomers would look for transit signatures or structural shadows if a megastructure were present, but so far, no such evidence has surfaced. Seth Shostak at SETI stresses that only a persistent artificial radio signal or a clear engineered spectrum would move the case beyond speculation, and nothing like that has been detected. Phil Platt, known as the Bad Astronomer, cautions that strange trajectories and volatile chemistry often have natural explanations, and reminds that extraordinary claims need extraordinary proof. Former Navy pilot David Fravor, who has investigated aerial anomalies, says 3I/Atlas's behavior matches known cometary dynamics, not advanced technology. NASA's public stance is direct. There is no threat and no evidence so far to suggest anything beyond a natural interstellar comet. The search for proof behind the engineered object theory begins with a checklist. First, signal interception. Astronomers monitor for persistent, non-random radio or optical emissions that repeat with the object's motion. No such signals have been detected, but every new observing session reopens the question. Next, isotopic sampling. If future spectra reveal ratios for carbon, oxygen, or metals that cannot be produced by known cosmic processes, the debate would shift overnight. Propulsion detection is another target. Any sudden change in velocity or trajectory, not explained by outgassing or gravity, would demand a new explanation. In August 2025, reports circulated about 3 faint objects trailing 3I/Atlas in JWST data. These so-called shepherds remain unconfirmed, but their existence would require careful, independent verification. Finally, transparency matters. Open access to all raw data, imaging, spectra, and tracking logs remains essential. Without it, the mystery only grows, and speculation fills the gaps that science has yet to close. On July 1st, 2025, the discovery of 3I/Atlas was officially reported to the Minor Planet Center, marking only the 3rd confirmed interstellar object ever tracked through our solar system. Detailed orbital solutions, such as an eccentricity of 6.08 and an inbound velocity of roughly 26 kilometers per second, prove its exosolar origin. Spectroscopic data from JWST revealed an exceptional carbon dioxide to water ratio of 8:1 and a dominance of nickel over iron, features uncharacteristic of known solar system comets. Despite rigorous forensic review, with media scoring 90 out of 100 for authenticity, and a flagged but inconclusive FAA radar incident, 3I/Atlas's true nature remains undetermined. No engineered signals, isotopic anomalies, or unambiguous evidence of artificial origin have been documented. NASA maintains there is no threat, but debate continues among experts. As of today, the core facts are public, but key questions about composition, possible companions, and origin are still open. 3. I/Atlas stands as a reminder. In science, even with hard data, mystery endures.